Maxwell's demon, one of the four mythical creatures in physics, is an imaginary being capable of detecting and controlling the motion of individual molecules. It was proposed by the physicist James Clerk Maxwell in 1871 to illustrate the potential violation of the second law of thermodynamics. The thought experiment involves a hypothetical scenario with an adiabatic container that is divided into two equal halves, separated by a small door controlled by the demon. The air molecules inside the container engage in random thermal motion and continually collide with the door. However, this little demon can accurately detect and control the direction of motion of each individual molecule, sorting faster-moving hot molecules to one side and slower-moving cold molecules to the other side. As a result, the originally temperature-equilibrated adiabatic container develops a temperature difference, with one side becoming hot and the other cold. In other words, this little creature can, without expending energy, transform a chaotic space into an ordered one automatically. This appears to contradict the second law of thermodynamics, but where does the flaw in this idea lie? In 1929, Rolf H. Landau first pointed out that if Maxwell's demon truly existed, the process of observing molecular velocities and acquiring information would inevitably result in additional energy consumption. Moreover, this process is inherently irreversible. Later, Shannon introduced information theory, which effectively refuted the existence of the demon. This is because obtaining or erasing information both require energy and, in dealing with molecular information, inevitably lead to an increase in entropy. Therefore, the entire concept of Maxwell's demon does not violate the second law of thermodynamics. Today, the laws of thermodynamics remain one of the fundamental principles of the universe, teaching us over centuries that entropy increase is irreversible. Heat cannot spontaneously transfer from a colder object to a hotter one, and to bring order to a space, additional energy must be expended. As an isolated system, the overall entropy of the entire universe increases over time, gradually transitioning from order to disorder. When the entropy in the universe reaches its maximum value, effectively, all energy has been converted into heat, and all material temperatures have reached thermal equilibrium. Scientists refer to this state as heat death, suggesting that the fate of the universe is likely to lead to darkness and ultimate entropy.